Hi, good afternoon. These are notes on constant proportionality part 2. So this is going to go along with the notes that we already took today in class. And this is going to be on page 62 of your notebook. All right. So constant proportionality is the constant value of the ratio of two proportional quantities, x and y, and it's a number that is multiplied by k. How to determine if a relationship is proportional from a graph? In order to for your graph to be proportional, it must be a straight line, and it must go through the origin. And the origin, remember, is 0, 0. To tell if a relationship is proportional from a table, you have to have your k value is a unit rate, so it's determined by y being divided by x, and only if the constant is the same, then your table is proportional. And then how to determine if a relationship is proportional from an equation is it must be in the form y equals kx. The x value is being multiplied by the constant of proportionality. So how does the constant proportionality compare with unit rate? They are equivalent. So your constant of proportionality is your unit rate. So that was a big recap of what we actually did today in class. So you actually were probably able to do some of this without my video. So let's do example 1. So let's find the unit rate here. So Joe can do 10 multiplication problems in 5 seconds. So 10 multiplication problems in 5 seconds. So at 0 seconds, so what's the unit rate? So he can do, so if we have 10 multiplication problems in 5 seconds, how many can he do in 1 second? So this is your problems, and this is your seconds. So if we want to get from 5 to 1, we divide by 5, so divide by 5, so you get 2. So he can do 2 problems in 1 second. So that's really, really fast. Okay, at this rate, how long should it take Joe to do 2 multiplication facts? Should take him 1 second. How about 18 problems? It should take him 9 seconds. And then we're going to fill in the table and we're going to graph. So at 0 seconds, he'll do 0 problems. At 1 second, he'll do 2 problems. At 2 seconds, he'll do 4 problems. At 3 seconds, he'll do 6. At 4 seconds, he'll do 8. And at 5 seconds, he'll do 10. So our equation that we can write for Joe is y equals 2x, where y is your number of problems, that's your k value, that's your constant proportionality, and x, that's your time in seconds. Okay. Now we're going to graph it. So we're going to label our x-axis with time, because that's our x value. So this is time, and we're going to tell ourselves in seconds. And then our y value is our number of multiplication problems. So we're just going to say number problems. Then we can decide how we want to count up by. So with time, we count up by 1 second if we want. So that's 1, 2, 3, 4, 5. You could have also spaced it out so it's not so close together. And then we can count up by ones, because really we can go all the way up to 10, which is as far as we need to go here anyways. So at 1 second, I can do 2. At 2 seconds, I can do 4. At 3 seconds, I can do 6. At 4 seconds, I can do 8. At 5 seconds, I can do 10. And at 0, I could do 0. So it does go through the origin. Okay? It has the same constant of proportionality every single time. And then my equation is in the form of y equals kx. So there's example 1. All right, example 2. So this time they give us a graph, and we have to determine if it's proportional, what the constant of proportionality is, write in the equation, and then we have to answer some questions. So let's look at this graph. First of all, does it go through the origin 0, 0? Yes, it does. So we can say yes, it is proportional. Because we can answer yes, we can give a constant of proportionality. So for every 4 pounds of sugar, there's 20 cups of coffee. So 20 cups of coffee for 4 pounds of sugar, because remember it's y over x. So this is the point 420. So 20 divided by 4 gives me, I need 5 pounds. No, sorry, I'm sorry, 5 cups for every 1 pound of sugar. That's a lot. That doesn't seem right. But it's just, I mean, it's the right math. So 5 cups of coffee and 1 pound of sugar. Ooh, that's okay. So now we're going to write the equation that represents us. So our unit rate, our constant proportionality, excuse me, is 5. So our equation is y equals 5x. Because our dependent is equal to our constant of proportionality times our independent. Now we need to find the number of cups of coffee you can make with 10 pounds of sugar. All right, so let's kind of, let's talk about what each is. So x is our pounds of sugar.
Is he gone already?
And then our y is our cups of coffee. All right, so pounds of coffee is x, so y equals 5x, and we want to know 10 pounds of sugar, so we can put 10 right here. So y is equal to 5 times 10. I'm sorry I'm writing this so badly. And then y equals 50. So 50 cups of coffee need 10 pounds of sugar. I did forget to fill in this table with you guys, so let's go ahead and fill it in based on what we're given here. So at 0 pounds of sugar, we have 0 cups of coffee. At 4 pounds of sugar, we have 20 cups of coffee. At 8 pounds of sugar, we have 40 pounds of coffee, 4 cups of coffee. At 12 pounds of sugar, we have 60 cups of coffee. And then at 16, we have 80. And if you can't fit all the points, it's okay. All right, so what we've determined from number 2 is that yes, this is a proportional relationship. Our unit rate or our constant proportionality is 5. Our equation is y equals 5x. And then to answer this question, it says how many cups of coffee would you need for 10 pounds of sugar? You would need 50 cups of coffee. And then here is our table. Okay. All right, down below, we're going to determine if the following tables and graphs below have a constant proportionality. If so, what's the constant proportionality? All right. So what you want to do is you want to take y and divide by x, and if you get the same number every time, then you're good. But really, you can't take 0 divided by 0 and get what you want, but I will tell you, because it goes through the origin, we can already say yes. But we can go ahead and fit it. Well, we can't actually, sorry. Just because it goes through the origin doesn't necessarily mean, because it could go through the origin and then draw a different picture. But what we're going to do is we can already say yes now, and then we're going to check the others. So 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. And because it's the same every time, now we can say yes. All right, this next one, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3 is 2 point something. It's like 2.6, I think. So 8 divided by 3. Yep, 2.6 repeating. And then 16 divided by 4 is 4. So this one is no, because your COP, your constant proportionality, is not the same every time. All right, now we're going to check this one. 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. And 20 divided by 4 is 5. So this one is yes. And if we do have a COP, we have to give it. So our constant proportionality is 5. And this one, let's go back over here. Constant proportionality is 3. Okay? And then number 4, is this a constant proportionality? Yes, because it does go through the origin. So that right here makes it a yes. This one is a no, because it does not go through the origin. This one does go through the origin, but remember, it has to be a straight line. So even though it goes through the origin, we have to say no, because not a straight line. This is actually called a quadratic function. This is the shape of a parabola. It's a negative quadratic function, and you guys will learn about that in Math 1. All right, so your homework is going to be the remainder of this, so numbers 7 and 8. If you have any questions, comments, or concerns, please ask me today or tomorrow in class, or leave comments down at the bottom. If I made any mistakes, please let me know. I know I was kind of talking fast and making some careless errors when I was writing, and I apologize for that. So please, again, write any comments down below, or come in tomorrow and ask anything that you might still need some guidance on. All right, have a great afternoon, and I will see you guys tomorrow.